Hello again. In this last recording, we're going to talk about some more limits at infinity involving e. All right, it's going to be related to stuff we did earlier in the semester. We talked about this limit as x approaches 0 of 1 plus x raised to the 1 over x. Now, as x approaches 0, the base is getting closer and closer to 0, but the exponent, let's just assume we're coming from the right, so we're talking about positive values. This is getting closer and closer to 1 raised to the, well, 1 over 0 is like going to positive infinity. And what do we do to make sense out of that? That's what we call an indeterminate form limit. But what we found was that turns out to limit out to e. The graph of that's kind of interesting. If I plot this in Desmos, it shows up as some dots going to the left. We talked about this in class a bit, that this expression is not defined for all negative values. It is defined for all values greater than, if we zoom in a little bit, greater than -1. If we zoom in a little bit, we get closer and closer to e as x approaches 0. Now, it says it's undefined there, and it is, because we can't plug in 0 to the formula, but that doesn't mean the limit doesn't exist, and the limit actually levels out to 2.718, which is the approximation for e. All right. Now, what we're going to do, how is this related to limits at infinity? We're going to make a quick change of variables. All right. We also talked about how the structure, or the specific variable x, is not as important, that the structure 1 plus that quantity raised to 1 over that quantity, as long as that quantity is going closer and closer to 0, that expression will approach e, as long as that quantity gets smaller and smaller. All right. Now, how this is going to be related to us, we're going to make a change of variable here, and we're going to replace the exponent, which 1 over x is approaching infinity as x goes to 0, by another variable. So we're going to let x equal 1 over n. So if we let x equal 1 over n, then if we reciprocate both sides here, we think about writing this x as 1, or x as 1 over x over 1, and if that equals 1 over n, if we flip both sides over, we're going to have 1 over x is going to be n over 1, which is just n. Okay, so, and we can see that as n gets bigger and bigger, x is going to approach 0. As n goes to infinity, 1 over n is going to approach 0. Flipping both sides over, we'd have 1 over x is equal to n, as we just shown. That's going to approach infinity as x goes to infinity. Now let's rewrite the formula for f of x. So we're going to replace the x by 1 over n in each case that we're seeing in x. Simplifying that numerator, that's equal to just n. And this new but related function we've got, I'm calling g, is 1 plus 1 over n to the nth power. And this is still in one of those indeterminate forms. All right, and as x approaches infinity, we'll just focus on positive infinity for now. We're still going to be having this expression be like 1 raised to the infinity powers. It's in indeterminate form. But we can use this relation in our previous work to compute this limit as we're going towards positive infinity. And this is really going to be actually towards positive or negative infinity, all right, for this example, but I'm just doing it for positive infinity. All right, so the limit of that expression 1 plus 1 over n to the nth power will be the same as, now we're just changing the variable back over in terms of x. So 1 over n is equal to x. N is equal to 1 over x. Now, I'm just going to erase that, what I circled there, and notice, as we said before, as n goes to infinity, what x is equal to, 1 over n, that is approaching 0. All right, so the limit as we're going to infinity for the function g will be the same as the limit as x is approaching 0 for the function f, which we already knew was e. All right, and that's just showing that we have this limit. All right, this is another important limit thing to know. And also, this is going for positive or negative infinity. All right, so I just added that on there. That it doesn't matter whether you're going to the left or to the right for that one. All right, let's look at that one graphically, and then we'll come back here. So I'm going to turn this graph off, turn this one on. All right, as we're going to the right, we're seeing we're going to level out at e. I'm just going to put the horizontal asymptote by drawing in or adding on the line y equals e, not 3, e. Just make that a dashed line. I'm just going to long press on this, hold it down, make this a little smaller. All right, here we go. And we can see it's going to level out at e. It's getting closer and closer. Maybe I made that too small. little better there. As we go to the right, towards positive infinity, and it levels off as we're going to the left towards negative infinity at E. All right, so that's verifying what we showed. So again, either way, as n gets really large, positive or negative, you're going to limit out to E. All right, also again, as we saw earlier, the structure doesn't matter as much, or sorry, the variable, excuse me, the structure matters, not the variable, as long as we have 1 plus 1 over a quantity raised to that same power, that same quantity, that will approach E as long as that exponent gets larger and larger without bound. All right, in absolute value, meaning could go to negative, could become more and more negative, could become more and more positive. Again, doesn't matter what this quantity is, as long as we have this match. We need 1 plus and then 1 over, though. The ones are the important key to this, so it has to really fit this mold. We have to have a 1 there, a plus sign there, and a 1 there. As long as the other two things match and are going to infinity or negative infinity, the limit's going to be E. All right, now let's do a couple examples with limits of infinity of this kind of expression that's in an indeterminate form. So to make it match the structure, we got to have 1 over some quantity. All right, so the way to do that for this first one is to simply divide the top and bottom of this fraction by 5. And when we do that, we're also going to do the following. So I'm writing this out. So now we're going to have 1 plus 1 over, again, the ones are important, the plus sign's important, x over 5. Now we need to make that exponent be x over 5. So to do that, we're going to take the x and divide it by 5. And then we'd want to also multiply it by 5. Again, multiplying by 1 doesn't change the value, changes the way it looks. So all we did was multiply by a convenient form of 1 there. And then using exponent properties, we can think about this as 1 plus 1 over x to the x over 5 power, raised to the x over 5 power, then raised to the 5th power. And notice we have the same quantity underneath 1 as we do have raised to the exponent. All right, so it fits our structure, and therefore this whole thing is going to approach or equal this in the limit in the end, E raised to the 5th power, because that expression in the orange parentheses is getting closer and closer to E. So that will limit out to E to the 5th power. Could verify this graphically also. Let's do one more like this. All right, notice we don't have a plus sign there, so we're going to have to remedy that. This time we're going to want to take this expression. I'm just going to drop the limit sign for a minute here, and we're going to rewrite this as 1 plus 1 over, and this is going to have to then be negative x over 2. All right. And dividing the top and bottom by negative 1 yields that result there. Again, we want 1 plus and then a 1 on top. Okay, and then we have to make the exponent match that also. All right, now our current exponent is 17x. We want that to be over negative 2. So we want to divide by negative 2. And then we're going to also have to compensate by multiplying by negative 2. Whenever we want to change the way an expression looks, we have to either add in a convenient form of 0 or multiply by a convenient form of 1, which we've done here. Now, 17 times 2 is negative 34, so we could rewrite this using exponent properties as 1 plus 1 over negative x over 2, put the negative sign in front of the fraction, raised to the negative x over 2 power. And then that will be further raised to the negative 34 power. Right? And therefore, this whole quantity, as x is approaching infinity, as long as the expression we have in the denominator of 1 here matches our exponent, that quantity will approach E as x goes to positive infinity or negative infinity, but this is going to go to E. Now the exponent stays, so E to the 34th power, which we could write as 1 over E to the 34th. So it's very close to 0 actually, because E to the 34th power is going to be a pretty large number. All right, that's it for this recording.